In section 1.4, we look at some other equations along with rational and radical equations. So let's start with an example of some other equations. Here we have a fourth degree equation and we want to solve for the real values of x. Now we haven't done a fourth degree equation yet, but I want you to see how this very much looks like a quadratic equation, except that it's not a quadratic equation because we have a fourth power. But we can make a substitution here. So what I'm going to do is attempt to simplify the equation by letting the variable u be equal to x squared. And you don't have to choose the variable u. That's the variable that I like to use, but you could use any other variable besides x. Now, why did I let u be equal to x squared? Well, if u is equal to x squared, then I can replace the x squared here with the variable u. Now the question is, what can I do with x to the fourth? Well, notice that if u is equal to x squared, and if you square both sides of that substitution, you get u squared is equal to x squared squared, which is x to the fourth. So that means that I can replace x to the fourth with u squared, and I can replace x squared with u. So this equation becomes 3u squared plus 5u minus 2 equals 0. So basically what we've done here is we have changed this into a quadratic equation by making a substitution. Now we can solve this equation by either factoring or the quadratic formula. I will choose factoring here because the factoring is relatively simple. So if you want to pause and verify this factorization, then we set each factor equal to 0. And if I solve for u here, I get u equals positive 1/3. And here we get u equals negative 2. But let's remember that we're not really solving for u. We're supposed to be solving for x because the variable in the beginning is x. So now what I do is I take the original substitution, u equals x squared, and I'm going to replace u down here and here with x squared. So this becomes x squared is equal to 1/3, or x squared is equal to negative 2. And I just have to solve these equations now. So to solve these, I take the square root of both sides. In the first equation, we get plus or minus square root of 1/3, which is the square root of 1 over the square root of 3. And this is plus or minus 1 over the square root of 3. And finally, we can rationalize the denominator to get a final answer of plus or minus radical 3 over 3. So we have two solutions there. And then we can do the same thing in the other equation. We could take the square root of both sides, and that gives us x is equal to plus or minus the square root of negative 2. And remember, when you take the square root of a negative, you can pull the negative out of the square root and make it into the imaginary number I. So these are the other two solutions. Now, if we go back to the beginning, I just want to point out that they only asked for the real values of x. So that means they only want real solutions. So anything that has the number I in it is not a real solution. So in the end, we're going to get rid of these answers because they don't want the non-real solutions. So the answers are x equals positive square root of 3 over 3 or negative square root of 3 over 3. Let's take a look at another example. So in this equation, we have t to the sixth power minus t to the third power is equal to 2. So once again, we have a higher degree equation. One of the common themes that you'll notice is when solving higher degree equations, you'll want to set the equation equal to 0. So I'm subtracting 2 from both sides to get 0 on the right-hand side. And once again, you should notice that even though this is not a quadratic equation, it resembles a quadratic equation. And all I need to do here is make a substitution. I'm going to let u equal t to the third power this time. And if I do that, when I square both sides, that gives us u squared is equal t to the 3 times 2, which is t to the 6. So now this equation, when we make the substitution, t to the 6th is the same as u squared, so we get u squared minus, and then t cubed is the same as u, and then minus 2 equals 0. And I can solve this by factoring, and once again, the factoring here is pretty straightforward. After that, we set each factor equal to 0 using the 0 factor property. And finally, solving for u, we get u equals 2 or u equals -1. But again, we're not solving for u, we're solving for t. So once we get the solutions for u, we have to substitute the original thing back in. So if u is t cubed, I need to put t cubed back in here. So that gives us t cubed is equal to 2, or t cubed is equal to -1. And now to solve for t, what I need to do is take the cube root of both sides of both equations. The cube root of t cubed is t, and the cube root of 2 is just the cube root of 2. So again, the reason we took the cube root is because the third power and the cube root cancel each other out. So this is one answer. And then for the other one, we have the cube root of t cubed, which is t, and then the cube root of -1 is actually -1. It's not a complex number. So here we have two real solutions. And again, if you're wondering why the cube root of -1 is -1, the reason for that is because -1 to the third power means -1 times -1 times -1, which is -1. Our next example is an example of an equation with rational expressions. Rational expressions just means that we have fractions, and usually we will have variables in the denominator of those fractions. To solve an equation containing fractions, we use the same technique that we used previously. And that technique is to eliminate the fractions. So we need to identify the least common denominator, which in this case is 3 times x. You'll notice that 3 and x appears in all of these, right? So now what I can do is multiply the left-hand side of the equation by 3x and multiply the right-hand side of the equation by 3x. On the left-hand side, the 3x's cancel out, and we just end up getting 4. On the right-hand side, we need to distribute the 3x to each one of these. So we'll get 2 over x multiplied by 3x plus 2 over 3 multiplied by 3x. And then keep in mind that 3x is 3x over 1. And the whole reason for doing this is because we can now cross-cancel x, and also 3 and 3. So in the end, we have 4 is equal to 2 times 3, which is 6, plus 2 times x, which is 2x. And now we have a linear equation that we can solve pretty easily. And our final answer should be -1. Now, when you have a rational equation, make sure you check your answers. Because one thing that you can't do when you have variables in the denominator is you cannot divide by 0. So as long as your answer doesn't create division by 0, then we should be fine. So let's remember that our answer here was x equals -1. If I plug that into here, notice that I'm not dividing by 0. So if we've done everything correctly, then answer should be correct. Okay? So when I say check, what I really mean is make sure to not divide by 0. If your answer creates division by 0, then you have to exclude that answer. So in this case, we're good. The answer is -1. Another example involving rational expressions, we have the equation 1 over x is equal to 2 over x minus 2 plus 3. We use the same technique, identify the least common denominator, which is going to be x multiplied by x minus 2. And then what I'm going to do is multiply both sides of the equation by that common denominator. And the whole point here is on the left-hand side, we can cancel out the x, which gives us x minus 2 times 1, which is x minus 2. And on the right-hand side, once again, we will distribute this to both terms. And that gives us 2 over x minus 2 multiplied by x and x minus 2 plus 3 times x minus 2. And in the first fraction there, we can cancel out the x minus 2's. And in the second fraction, nothing cancels. All right, let's see what we have now. So in our next step, let's just clean things up a little bit. Here we have 2 times x, which is 2x. And here we have 3x multiplied by x minus 2. So 3x times x is 3x squared, and 3x times -2 is -6x. Now we can see we have a quadratic equation. On the right-hand side, we can combine 2x minus 6x to make -4x. And then keep in mind, when you have a quadratic equation, you want to make sure you set it equal to 0. So I'm going to subtract x and add 2 to both sides. And when we do that, we get 0 equals 3x squared minus 5x plus 2. And from here we can factor. And you can use a magic x if you want. So 3 times 2 is 6. And we have -5 in the middle. And the factors of 6 that give us -5 for a sum are going to be -2 and -3. So when we factor this, we're going to have x minus 2, x minus 3. But then remember to divide each one of those by 3. It's very important to remember that step. And finally, we end up with 3x minus 2 times x minus 1. And again, what we're doing here is we're moving this up here. And on the second one, 3 divided by 3 is 1. So now we set these equal to 0. And for the first equation, we get x equals 2/3. And for the second one, we get x equals 1. And then once again, we just need to make sure that we're not dividing by 0. So if I go back to the beginning of the problem, I want you to notice that in this problem, x cannot be 0 because that would make this denominator 0. And x cannot also be 2 because 2 minus 2 is 0. But we didn't get 0 or 2 for our answers, right? We got 2/3 and we got 1. So these answers check out. They're okay. Okay, another example of rational equations or equations with rational expressions is this one here. And I just want you to notice that in each of our examples, they've been getting a little bit more complicated each time. First thing I want to do here is factor the denominator on the other side there. And that factorization again, is relatively straightforward. It should be x plus 3 times x minus 2. These don't need to be factored as they are already in factored form. So from here, we can identify our least common denominator is x minus 2 times x plus 3. Notice that those are the factors that we have. And then we're going to multiply both sides of this equation by that common denominator. On the left-hand side, we distribute, and again, you don't have to show all of this step here. I'm going to show it just for the sake of the video to make sure that everyone is able to follow along. But a lot of students end up kind of figuring out what happens when you multiply, so they can kind of see it in their head. And if that's the case, then you don't really have to do what I'm doing right here. Okay? Now on the right-hand side, we don't have to distribute, so we can see right away that these cancel here and these cancel here. So all we have on the right-hand side is 12. On the left-hand side, though, you'll notice that we can still do a little cancellation, x minus 2 here and x plus 3 here. So if we multiply what's left, we have x plus 3 times 1, which is x plus 3. Here we have x minus 2 times 6, and I'm going to write that out as 6 times x minus 2, and then we have 12 on the right-hand side. So don't skip steps if you struggle with little details. Make sure you show everything. So that's what I'm doing right here. I'm not skipping this step. I'm writing it down. Now my next step, I will distribute here. This gives us x plus 3 plus 6x minus 12 equals 12. Combined like terms, 1x plus 6x is 7x. Positive 3 and negative 12 is negative 9, is equal to 12. If we add 9 to both sides, we get 7x is equal to 21. And then dividing by 7, we end up getting x equals 3. Now again, remember, you have to check that answer. So if you go to the beginning, you'll notice that x cannot be equal to 2 here, and x cannot be equal to negative 3 here, and same restrictions on the other side here. So as long as we don't get one of these answers, we should be okay. And the answer we got was positive 3, so there's no problem with positive 3. All right, so that is our answer, and it checks out. Now let's take a look at an equation containing a radical. So in this equation, we have the square root of 3x plus 1 plus 2 is equal to x minus 1. When you have an equation involving a radical, you want to get rid of the radical. So the goal is to eliminate the radical. Now to do that, first thing I want to do is isolate the radical. So what that means is I don't want to have this plus 2 added on to the radical. So I'm just going to subtract 2 from both sides. That's going to give us the square root of 3x plus 1 is equal to x minus 3. Now the reason we want to isolate the radical is because we have a property that says if you have the square root of a and you square that, you just get a. So what I'm going to do to get rid of the radical here is I'm going to square both sides of the equation. So on the left-hand side, what happens here is we just get 3x plus 1 because the square and the square root cancel each other out. On the right-hand side, we have x minus 3 to the second power. And that needs to be multiplied out. So when you FOIL this, you should get x squared minus 6x plus 9. And then from there, notice that you have a quadratic equation. So we're just going to subtract 3x from both sides and subtract 1 from both sides. And this gives us 0 equals x squared minus 9x plus 8. So we now have a nice quadratic equation, and we can factor in this case. Again, the factoring here, I believe, is pretty straightforward. Should be x minus 8 times x minus 1. And from there, we set each of those factors equal to 0, and we end up getting x equals 8 or x equals 1. Okay, now just like before, you must check your answers. And this time, when you check, you have to actually plug it in. So let's take our original equation, which was the square root of 3x plus 1 plus 2 equals x minus 1, and let me check each of these answers. So first I'll check the answer x equals 8. If I plug in 8, we get the square root of 3 times 8 plus 1 plus 2 equals 8 minus 1. And I'd like to put a little question mark there because I'm trying to see if this is true or not. If you do the math, 3 times 8 is 24 plus 1 is 25. So we have the square root of 25 plus 2 is equal to 8 minus 1, which is 7. And this says 5 plus 2 equals 7. And that is correct, right? Because that says 7 equals 7. So this means that the number x equals 8 is confirmed to work. Now let's try x equals 1. When we check x equals 1, we do the same thing. We're going to plug in 1 for x on both sides of the equation. And this is going to give us the square root of 3 times 1 is 3 plus 1 is 4 plus 2 is equal to 1 minus 1, which is 0. And this says that 2 plus 2 equals 0, which says 4 equals 0. And this is clearly not true. And so this means the answer x equals 1 does not work. And when an answer like this doesn't work, we call this an extraneous solution. So it's not really a solution because it doesn't make the original equation true. So the only answer to this problem is x equals 8. Our next example is also an equation containing a radical, but this time we have two radicals. So notice that we have a square root here and also a square root here. When this is the case, what you want to do is isolate one of the radicals. So what I can do to both sides of the equation here is I can add the square root of x plus 4 to both sides of the equation. That is going to cancel this out. And then we end up with the square root of 3x plus 1 is equal to 1 plus the square root of x plus 4. Okay, so what I've done there is I've isolated this radical. It's all by itself now. From here, we do the same thing that we did in the last question. We're going to square both sides. When you square on the left side, these cancel out, and you end up with just 3x plus 1. On the right-hand side, when you square this, you have to multiply it by itself. And this is where the problem can get a little bit tedious. So let's go ahead and do the multiplication. We're going to do 1 times 1, 1 times the second term, and then multiply here, and multiply here. And if we do those multiplications, we get 1 times 1 is 1, plus 1 times the square root of x plus 4 is the square root of x plus 4, plus the square root of x plus 4 times 1 is the square root of x plus 4. And finally, the square root of x plus 4 times the square root of x plus 4 is x plus 4, right? So remember that when you have the square root of a times the square root of a, that gives you a. So the radicals cancel on that last one, which is kind of nice. Now if we simplify on the right-hand side, we have a 1 here. We have plus 4 there, so that equals 5. We also have an x here. So I'm going to write that as x plus 5 plus And then notice that here you have 1 radical plus 1 radical. That's going to be 2 radical x plus 4. So some good news and some bad news. The good news is that on the left-hand side, we got rid of the radical. But on the right-hand side, the radical is still with us. But this is an improvement because now the equation only has 1 radical. So now we do basically the same thing that we did in the last problem. And that is, we need to get this radical by itself. So we need to isolate this. And the way I can do that is by subtracting the other terms from both sides. So when I subtract x and when I subtract 5, those are going to cancel. On the left-hand side, we get 2x minus 4. And on the right-hand side, we have 2 times the square root of x plus 4. Now from here, there's a couple of different things you could do. One thing we could do is we could divide by 2, since these are multiples of 2. But sometimes this number will not divide evenly into those numbers there. So if that's the case, I wouldn't actually want to divide by 2 here. So I'm going to take the more generic approach, which is now just square both sides. So on the left-hand side, we get 2x minus 4 times 2x minus 4. On the right-hand side, when you square this, you need to square the 2 and square the radical. It's a little different because we have multiplication here. So we're going to end up with 2 squared times the square root of x plus 4 squared. 2 squared is 4, of course. And then in the second one, the radical and the square cancel out, and we just get x plus 4. On the left-hand side, we are going to multiply this out like normal, and that gives us 4x squared minus 16x plus 16. And you can pause for a second here to make sure that this is correct. Continuing, on the right-hand side of the equation, we can multiply this out and get 4x plus 16. And then I want you to notice that we once again have a quadratic equation. So when you have a quadratic, you want to subtract the terms from one side to set it equal to 0. So I'm going to subtract 4x from both sides, subtract 16 from both sides. This gives us 0 on the right-hand side. And on the left-hand side, we have 4x squared minus 20x. We get a nice little bonus cancellation right here. So now how do we solve this equation? Well, remember your factoring techniques. So what I have here is a greatest common factor of 4x. If I factor that out, we get 4x times x minus 5 equals 0. And then we can set each of these factors equal to 0, which gives us, finally, x equals 0 or x equals 5. Now we have to check those answers, right? So we're not quite done. So if I go all the way back to the beginning, right, which is way up here, let's make a little space here. I have the equation square root of 3x plus 1 minus the square root of x plus 4 is equal to 1. And I'm checking my two answers. One of the answers was x equals 0. So let's plug that in and check. So if I do that, I have the square root of 3 times 0 plus 1 minus the square root of 0 plus 4 is equal to 1. This says the square root of 1 minus the square root of 4 equals 1, which means 1 minus 2 equals 1, which means negative 1 equals positive 1. And this is not true. So this is not an answer. The other answer we had was x equals 5. If we plug in x equals 5, we get the square root of 3 times 5 plus 1 minus the square root of 5 plus 4 equals 1. This tells us the square root of 16 minus the square root of 9 is equal to 1. And that means 4 minus 3 equals 1. And this, of course, is true. because 1 is equal to 1. So x equals 5 is our only solution here. So if I go back down to the bottom where we had these two solutions, 0 does not check, 5 does check. So the only answer here is x equals 5. Let's take a look at an application problem. In this problem, it says a theater club arranged for a chartered bus trip to a play at a cost of $350. To lower the costs, 10 non-members were invited to join the trip. The bus fare per person then decreased by $4. How many theater club members were going to the trip? So the first thing we want to do is define a variable to represent what we're solving in this equation or in this problem. So I'm going to let x equal the number of club members, theater club members. Okay? Now we know the total cost is $350. They tell us that the cost per person decreased by $4 when we added 10 non-members. So how do we get the cost per person? The cost per person is the total cost divided by the number of people, right? So the cost per person was $350 divided by the number of club members, which was X. So this was the cost before adding people. Now it says when we add 10 people, the cost decreased by $4. So the cost after we added 10 people is 350 divided by the total number of people, which is going to be X plus 10. This is the cost after adding. And what they tell us is that this cost is $4 less than the other cost. So what that means is the cost before we added people decreased by $4 when we added 10 people to the bus. Okay? So the average cost now is $4 less than the average cost before we added people. This is the equation that we need to solve. To solve this equation, I'm going to multiply both sides by the least common denominator, which is x times x plus 10. When we multiply this out, we end up getting 350 times x plus 10 minus 4 times x plus 10 is equal to 350 times x. On this side, we get simple cancellation. On the left-hand side, we talked about how to multiply that out earlier. Now let's go ahead and do the math. 350x plus 3,500 minus 4x squared minus 40x equals 350x. Now, if I subtract 350x from both sides, we get this really nice cancellation here. And that's going to leave us with these terms. And I'm just going to put those terms in order. And now to solve this, what I can do is I can use factoring or the quadratic formula. So what I'm going to do is first factor out a negative 4. That's going to give us x squared plus 10x minus, what is 3,500 divided by 4? Well, if you do the math there, you get 875. And these numbers are really bad, right? I mean, how are we going to factor this? Well, it is possible. All we need to do is make a factor tree, and we need to break it down into its components. So 875 is going to be 25 multiplied by 35. So I knew that 25 goes into 875 because it ends with the number 75. And it looks like I got really lucky here because I want you to notice that 35 and 25 have a difference of 10. So actually, we can factor this by just using those two numbers, 25 and 35. And we're going to need a positive 35 and a negative 25. And now if I set each of those factors equal to 0, we get either x equals 25 or x equals negative 35. Now x is the number of people that went on the bus, right? The number of club members. So it can't be negative. So it must be 25. Now the other thing I want to point out is we don't do anything with the negative 4, right? Because when you're solving for x, that factor doesn't have an x, so it doesn't contribute to the solution. So it looks like we had 25 members on the bus initially. And what were they asking for? Yeah, that's what they were asking for. How many theater club members? So the answer is 25. Now you can check your work here. Let's check our work. The average cost is equal to the total cost, which is $350, divided by the number of people that go. So the average cost if 25 members go on the bus is 350 divided by 25. And if you do that math, you get $14 per person. The average cost afterward is $350 divided by the total number of people. Well, the total number of people after you add 10 non-members is 35 people. And 350 divided by 35 is $10 per person. So how do we know our answer is correct? Well, they told us that when you add 10 people, the average cost goes down by $4. And that's what happened here, right? The average cost before was $14. Now it's $10. So it looks like our answer of 25 members going on this trip is correct.